Hi everyone, we are continuing Module 1. We are in Topic 2. This is Lesson 2. And we are starting here on page 77. So this is called Slicing and Dicing Composite Figures, and that'll be one of the terms we have here in just a moment. Our learning goals: decompose composite geometric figures into rectangles, parallelograms, and/or triangles to determine their areas. Solve real-world problems by composing and decomposing shapes into triangles and rectangles. So just a quick review says use a formula to determine the area of each figure. Remember, I want you to always be writing the formula for each of the figures so that you can then get used to substituting in the correct information in the right spot in the formula. If you get used to doing this now, it'll help down the road when you get into some higher level, more difficult math. You'll be glad that you've learned this process. So first we have a parallelogram, which is area equals base times height. Now, the height of the parallelogram is usually shown by a dotted line, and the height intersects with the base in a perpendicular intersection, which means it has this 90-degree angle right here. So this is then the height. This is the base. We know that the bases are parallel to one another. So we have the area is, the base would then be the 22, and the height is 10.5. I'm going to put 10.5. Doesn't matter if you use the fraction or the decimal. So then when we multiply, area equals, notice I'm writing area equals each time. We have 22 times 10 is 220. And then half of the 22 is 11. So if I added those together, I get 231 meters squared. Okay, moving on to the triangle. So the formula for the area of a triangle, remember if we took the parallelogram and we cut it in half, we would have triangles. So the formula for a triangle is the same as the parallelogram, but just half of it. So it's half times the base times the height. So again, we're going to rewrite our base. Same thing with the parallelogram. Our base is right here at the bottom. Now, our base could be on the side depending on the position. Like our triangle might actually be shaped this way on the page. The 11 is still on our base. It's not necessarily on the bottom. We know the height is shown with this dotted line that has, it almost looks like an H here for height. It forms a perpendicular intersection, and the height goes from the base of the triangle to the highest point of the triangle. So I know that's the height, and if this is the highest point and it has a perpendicular intersection with the base, then the 11 must be the base. So 1/2 times the base of 11 times the height of 7. Then we have half of 77, which our area is then 38.5 centimeters squared. Okay, so then we have the trapezoid. So the area of the trapezoid formula is area equals, and we developed this formula last week in class, half times the height times the sum of each of the bases, and they call it base sub 1 plus base sub 2. Now, sometimes you see it written as area equals half, and then they'll add the bases and then multiply by the height. Either way, it doesn't matter. You get the same thing. Multiplication is commutative, so it will work whether the height is here in between the half and the sum of the bases or here at the end. So area equals half. So again, our height connects the bases of our trapezoid, forming a perpendicular intersection here at the second base. So our height is the 30. And then our bases is what the height connects together. So it connects the 35 and the 65. So then we have half of 30 is 15. 35 plus 65 is 100. And then we have 15 times 100 is 1,500 yards squared. Now you might have just added this first and gotten 100 and then did the times 30, got it 3,000, and then half of 3,000, 1,500. Either way, you get the same thing. Moving on, compose or decompose. I am on page 78. So it says consider each composite figure. So before we read on, take note. A composite figure is a figure made up of one or more, of more than one geometric figure. Show how you could decompose each figure into two or more familiar figures. Describe the shapes that make up the composite figure. So how could we break this up? I do see quite a few different possibilities here. One way that I could decompose this is to draw a line here and here. And if I did, I would have a rectangle, rectangle, and a rectangle. So that's just one way that you could decompose it. I'll just sketch out another way here quick. You can pick which one you would like to show in yours. You don't have to do both, but it could go straight across here and here, which we would then have a rectangle down here. And I don't have exact measurements. These might be squares, but we know for sure that we could classify those as rectangles because a square is also a rectangle by definition. Okay, what about letter B? So letter B, you could go right here, which I would then have a rectangle and a trapezoid. The other thing that you could do for this one, my sketch isn't the greatest, that's okay, you'll get the idea, is I could draw it this way, and then I would have the rectangle down here and the trapezoid at the top. Okay, remember you can pause along the way as you need to. Number 2 says show how you can compose each figure into a larger familiar figure. Describe the shapes that make up the composite figure. So let's just back up just a second. So in number 1, let's say we did figure out the different areas of these 3 rectangles. Let's say we said that this one was 20, this was 10, and this was 20 as well. What would the total area be of that entire shape? Yeah, it would be the 20 plus 10 plus 20. So 20 plus 10 plus 20. So right, it would be 50, and you would have to add those together. Same with here, I would add the rectangle and the trapezoid. What about here? So what would I do if it wants me to compose a larger familiar figure? So if I close this in, I have a great big large rectangle. Let's say this is 20 by 15. If that's 20 by 15, then the entire shape would be 3,000, I'm sorry, 300. But what about this? This really isn't here. I enclosed it. So let's just say this is, oh, I don't know, 5, and this is 4. Then this area would be 4 times 5, 20. So what would I do with this 20 then? Knowing that I enclosed it to include it, but it's not really included, what would I have to do? Right, I would do the 300 minus the 20 for a total area of, let's say, 280. Okay, and I know I'm using different numbers than what I have up here. It's just kind of for ease in explaining this, and they're not the measurements of these shapes. Okay, letter B, to close it in, I could go like this. So I now have a large rectangle. Okay, so I have a large rectangle, and I have this smaller triangle here. So again, on this one, I could figure out the area of the entire rectangle, and I could subtract off the triangle. And that would get me the area of my composite figure. Okay, so that's page 78. Moving on from there. Page 79, consider the blueprint of a floor plan for a kitchen, dining room, and living room combination. Suppose the homeowner wants to replace the floors in all the rooms. Wanda says she can determine the total area of flooring needed by composing the blueprint into 2 rectangles. Naveed says he can determine the total area of the flooring needed by composing the blueprint into 1 large rectangle and subtracting the unused area. Who is correct? So go ahead and pause and see if you can come up with an answer and write it right here in this box, the thumbs up, thumbs down area. Okay, so I hope that you paused that and gave that a try. So as I look at it, Wanda says she could use 2 rectangles. So I see some measurements here at the kitchen and here along the dining room and here along the side of the living room. So I guess I could see one great big giant rectangle here. And then I can see another one here at the kitchen. So yeah, I think she'd be able to do that. I think there's enough information given here. She could do that. So I'm going to say Wanda's correct. But what about Naveed? He says he can determine the total area by composing the blueprint into 1 large rectangle and subtracting the unused. So for his, so he's saying 1 great big large, so maybe this whole thing, but then I guess I would extend it down here and then subtracting the unused, which I guess this would be the unused area. Well, can I figure out this area? I know it's 10 this way. Can I figure out this distance here? And I think I can. I know the entire length is 30, and I know the kitchen is 12. So from here to here is 12. And if from here all the way over is 30, then what's this part? So this is 12. I know it's 12 because it tells me here. And this is telling me it's the 30 all the way across. So 12 plus what gives me 30? Right, 18. So this rectangle here is a 10 by 18. So I think I can figure out that area and subtract it from the total. So I'll say Naveed is right as well. So I think that they are both correct. Letter B. So show how to calculate the amount of flooring needed using Wanda's method. So Wanda's, remember, she had the dining room and living room combination. So dining room and living room. And it was a rectangle, so I'm going to say the area equals length times width. So that dining room and living room has a length of 30 and a width of 15. So area equals 30 times 15. So that area is 450. 3 times 15 is 45, but it's not just 3 times 15, it's 30. So it's 10 times more, so I need 10 times more than 45, 450. And then I think I have enough for the kitchen as well. The kitchen is a 12 by 10. So kitchen, again, area equals length times width. So the area equals 12 times 10, or 120. And these are feet squared. So when I add those together, 450 plus 120, I get 570 square feet. Well, technically we should get the same thing for Naveed, so let's see if we do. Show how to calculate the amount of flooring needed using Naveed's method. So remember his, we said we were going to do the entire rectangle. I'm going to start with that. So that entire rectangle is 30 by what? So I know it's 15 to here, but how far is the rest of it? Well, this line matches up with this, and I know the kitchen on that side is 10 feet. So this must be 10 feet as well, making the entire length 25 feet. So for Naveed, the larger rectangle, area equals length times width. Area equals, did we say here, 30 times 25. 30 times 25. Now 3 times 25 is 75, 3/4. But it's not 3 times, it's 30 times, which is 10 times more. So 10 times more than 75 is 750 feet squared. But we're not dealing with the entire 750. We have to get rid of this part, which we determined was a 10 by 18. So smaller part, the smaller rectangle, had an area of, let's see, the length was 18 and the width was 10. So the area equals 180 feet squared. And then we're going to subtract those. And it's going to equal the area of the floor plan. So 750 minus 180 . 570 square feet. Did they both get the same answer? They sure did. Okay, so I'm going to pause there at page 79, and we will pick this back up on another lesson.